Right. In the previous video, we saw an intuitive method for solving polynomial inequality, specifically just for quadratic. And we noticed that the things that mattered were the shape, whether it's going up or down, and the x-intercept. That's enough to determine, for example, if you have the x-intercept and the shape is going upwards, then these upward arms are where it's positive, and the bowl shaped thing is where it's negative. Whereas with the same x-intercept, if it was downward facing, then the bowl area is where it's positive and the arm area is where it is negative. So these are the only two things that matter. So we can develop a general method based on that information that we are concerned with the shape and the intercept. Example, let's say I want to solve for x squared minus x minus 20 is greater than 0. Step 1 is you solve for the function equals 0. In this case, I don't have to use the formula, I can just factor it, and I get x is 5 and negative 4. So this is where, these are the x-intercept, right? This is where the function crosses the x-axis. Let's call them boundary values. And we mark these on a number line. Now when you do this, you are dividing the number line into three distinct regions. The one that's left to negative 5, negative 4, the one that's right to 5, and the one that's in between. Now from each of this created region, we pick a test value, which means that from left to negative 4, we pick a number here. Between negative 4 and 5, we pick any number here. Example 0, example negative 5. And to the right of 5, we pick any number, example 6. For each of these numbers, we evaluate the function for each of the test value. So f of negative 5 is 10, which is positive. F of 0 is negative 20, which is negative. F of 6 is 10, which is positive. Now, if you've done this correctly, they should alternate between positive and negative. And it is obvious when you look at the graph of the function. Step 5 is that the sign of the test value is the sign of the function in that entire region. Meaning, because f of negative 5 was positive, everything here is going to be positive. Because f of 0 was negative, everything here is going to be negative. And because f of 6 was positive, everything here is going to be positive. And last step is you report the region where fx is greater than 0 or less than 0 as required. In this case, it belongs to negative infinity to negative 4, union 5 to infinity. Again, the endpoints are not included because it's a strict greater than and not greater than or equal to. Let's look at another example. First of all, I bring all the terms to one side. Now in this case, it's a less than or equal to 0. So first, I need to find my x-intercept, right? So I use the quadratic formula that gives me plus minus 4 minus 16 or plus 16 over 8. Negative 2 plus minus root 20 over 8. That's not going to be neat. 2 root 5 over 8. So what I have is negative 1 plus root 5 over 4 and negative 1 minus root 5 over 4. So this is a positive number right here, and this is a negative number right here. Now let's pick test points. Test points are going to be 0. Test points, 1 here, 1 here, 1 here. Now, I need to estimate this value. Root 4 is about 2, so root 5 is slightly over 2, right? So this number is slightly over 3, right? This is slightly, it's like negative 3 points something something. Divide by 4 means that it is greater than negative 1. So I can pick negative 1 to be a test point. Similarly here, this top number here is going to be 1 point something something over 4, which means it's less than 1. So I can pick my test point to be 1. f of negative 1 is 4 negative 1 squared plus 2 negative 1 minus 1. That's 4 minus 2 minus 1, which is 1, which is positive. So it's positive here. F of 0 is clearly 0 plus 0 minus 1, which is negative. So it's negative here. And f of 1 is 4, 1 squared plus 2, 1 minus 1, which is positive. Again, as expected, if things are done correctly, for the quadratic case, the signs should alternate between positive and negative. Now we want the negative version, and there is an equality sign, which means that in this case, we will also include the endpoint. So x belongs between the negative root 5 minus 1 over 4 and root 5 minus 1 over 4. All values in between are negative. That's the solution set.